In this lecture, in Module 5, we will look at the phosphorus storage and release from P-impacted soils. And at the end of Module 5, we will understand what happens when manure remains in the soil for a long time. What is the difference between P added as manure and P added as inorganic fertilizer? How P loss from a soil can be reduced? What is the difference between P found in nature, that is phosphatic soils, and anthropogenic sources of phosphorus? How do we use SPSC for risk assessment of wetland soils? First of all, let us look at the long-term contribution of phosphorus from agricultural lands, and we'll be taking a look at legacy phosphorus in the Lake Okeechobee Basin. Soils of the Lake Okeechobee Basin are variable, but predominantly Spodosols, and we looked at P loss via different pathways from a spodosol in an earlier lecture. That is in Module 3, Lecture 2. Now, the depth to the spodic horizon will be an indicator of how P can be lost from a soil. So, the name of the soil series is determined in part by the depth to the spodic. As depth to the spodic horizon increases, the chances of P loss from the soil via subsurface drainage increases with a concomitant increase of P that subsequently reaches surface water. Let us take a look now at the relationship between SPSC and water quality. The relationship of P saturation ratio and the soil P storage capacity to water-soluble P was discussed earlier. Minimal P loss occurred when SPSC is positive, that is, when the soil is below the threshold PSR, and the P loss increases with negative SPSC. So SPSC can be used in evaluating the fate of legacy P in Spodosols. The total depth considered for all soils in the following examples is 120 centimeters or 1.2 meters. We will now look at a minimally P-impacted pasture soil on Mayaca. So Mayaca has a shallow spodic, shallow in comparison with, say, Immokalee or Pomelo. The SPSC for the A and E horizons in this particular soil is close to 0. So soils will be a P loss risk if P is added beyond the crop requirement. Now let us look at a heavily P-impacted soil. The soil is again on a Mayaca. The SPSC for the A and E horizons is negative, so there is a greater risk of P loss from the soil compared to the soil we looked at earlier. Next, we will look at a P-impacted cattle holding area on Immokalee. Immokalee soils have deeper spodic than the Mayaca. Therefore, if loaded at identical depths compared to the Mayaca, there is a greater risk of P loss from the soils. In this particular example, the SPSC for the A and E horizons is negative, and the spodic occurs at a greater depth. Therefore, there is definitely a greater risk for P loss from this particular soil compared to that of the Mayaca, which we talked about in a previous slide. Next, we have the P-impacted cattle holding area on Pomelo. Pomelo is a very, very deep soil, and it's deeper than either the Mayaca or the Immokalee. The SPSC for the A and E horizons in this case is negative, and the spodic horizon does not occur within the 120 centimeter depth considered. So there is definitely a greater risk for P loss from the soil than a Mayaca or a Immokalee at a similar P loading, When I say the Spodic doesn't occur till 120 centimeters, that means we are still in the E horizon and P loss would be great. So in summary, as manure deposited on a soil increases, the SPSC decreases, even when the additions are on the same soil type. When SPSC is close to zero in the surface horizon, there will be a P loss risk if P is added beyond the crop requirement. When A and E horizons of heavily P-loaded soils have negative SPSC, the soils will constitute a P loss risk. Dairies located on soils with a shallow Spodic horizon had remaining storage capacity to a depth of 120 centimeters even when the P loading was high. The likelihood of P loss with subsurface drainage above the Spodic is higher for a deeper Spodic than when a shallow BH horizon exists. Finally, a soil such as pomelo does not have a Spodic horizon within the top 120 centimeters, at least in this example that we have looked at. The soil has negative SPSC throughout the profile down to 120 centimeters. Thus, P loss can continue both horizontally and vertically until it contacts a more P-retentive BH horizon. Now, let us look at what happens to P after a dairy is abandoned. This particular dairy had been in operation for 11 years and abandoned for 18 years at the time of soil sampling. So when a dairy is no longer active, manure P will continue to move both horizontally and vertically when in contact with water. The SPSC of this manure-impacted dairy soil on Immokalee has moved down to a depth of 120 centimeters. The BH1 horizon has negative SPSC, so even without any new additions of manure, the SPSC of this soil in a few years will be negative down to 120 centimeters. Now let us look at what happens when the dairies have been abandoned for a long period of time. We have 5 different dairies here, and they have been abandoned for various periods of time. The locations were heavily manure-impacted areas, and we have a varying depth to the Spodic. They belong either to Myakka or the Immokalee soil series. What we notice is the SPSC up to 120 centimeter depth is negative for all these soils. In other words, it has been P-impacted to 120 centimeter depth even after abandonment of the dairies. So what are the factors we need to consider for sustainable dairy farming? Well, within any given dairy, the soil type often varies spatially. Therefore, activities within a given site should consider the soils on which the activities are planned. It is preferable to keep the heavy manure P application areas, example the cattle holding or traffic areas, on a soil with a shallow Spodic horizon compared to one with a deeper Spodic, unless the shallow Spodic is in a very poorly drained position with very high runoff potential. Here are some notes on SPSC, just as a review. SPSC is additive, so it's possible to obtain a cumulative value to any desired depth that could be used as a management tool. The SPSC value down to 120 centimeter depth in the above examples was an arbitrary depth chosen for illustrative purposes only. The calculations can be made for SPSC to any desired depth as long as you know the bulk density and the depth of the particular horizon you're looking at. The capacity of retentive subsurface horizon, example the BH, BW, BT, may not be assessed when they are below the water table. In effect, these horizons may be short-circuited if P is transported laterally above them. The location of a water table in a low P impacted soil would have minimal effect on P release from the soil unless the soil continues to be loaded with P, at which time the surface horizons of the soil would be a P source, that is SPSC, would become negative. The SPSC is a tool that considers both P additions and the capacity of a soil to retain P. It is not necessary to know the P application history or other site-specific factors like the age of the dairy, the length of time it has been in operation or abandoned, the previous land use, etc. The absolute value of SPSC, if positive, will indicate the amount of P that can be added before the soil becomes an environmental risk, that is, prior to SPSC becoming zero. Here are a few of the related references.